All right, today's lesson is 15.1, Nets and Surface Area. We're going to jump ahead to chapter 15, and we're going to focus on today's essential question: how can you use nets to find surface area? All right, so surface area is the best way to think of that is it's if you were to paint an object on the outside, that is going to cover the surface. All right, so if you look at this three-dimensional object right here, that's a cube, and so the surface area would be the area of all of the faces that go around. All right, and this is our vocabulary for today. It's called a net. A net is a two-dimensional pattern of shapes that can be folded. So I'm not sure if you remember when you were younger, you would have cut out a shape like that and folded it up to make a three-dimensional object. And out of these two right here, only one of those will actually fold up. And so what you want to have is basically two little flaps right here, kind of that where this one's going to fold up to start it, and then this one's going to cover it. And then if you tried that right here, this one would fold up, but then when you fold it over, you're not going to have a cover. This one's going to overlap. All right, so you need to have two flaps that are kind of on the opposite sides. And so the whole idea here is just the concept behind it. All right, so if you're going to calculate surface area, which we're going to do in a few minutes using our formulas, you would find the area of one of our squares, so the base times the height of that one square, and then you would multiply it by 1, 2, 3, 4, 5, 6. So that is how you would calculate the surface area. So out of these two right here, which one is actually a net? And again, applying the whole idea, we have our little edges right here, which are going to fold up. And this one right here, if you try to cut that out and to just fold it on its edges, it's just going to go all the way around. You're not going to have a top or a bottom to it because it's all in the same kind of body. All right, so that's the idea here. We're going to now look at some different types of shapes. Take a look at this one. All right, so this is surface area of a pyramid. All right, so this one's a little bit different. All right, so again, the definition of a surface area is the sum of its areas of its faces. And so this one is not just a square or a rectangle. This one has triangles. All right, so a pyramid, I know you guys know what this is. You studied it in social studies. It's a three-dimensional figure whose base is a polygon and whose other faces are triangles that meet at a point. All right, so the whole idea here is you need to find the area of the triangle, and then you see that there is one on the back there, 2, 3, 4 triangles that you're going to have to multiply together, and then you add it to the square base down below. All right, so the net helps us calculate that, and you'll see that here because it's unfolded now. So let's take a look at our triangle. All right, so you see our height right away is right there. So you got to remember the triangle formula. It's 1/2 base times height. All right, so what is the base of my triangle? The base is 16. All right, so it's 1/2 16 times the height, which is 17. So this one sets up well because you can do in order of operation right here. You can go across. 1/2 of 16 is 8, and then you multiply 17 times 8. So there we go. Carry the 5. We have 136. All right, so that's going to be for one triangle. You need to do that for 1, 2, 3, 4 of them. All right, so this is going to get you the area now of your triangles only, but now you also have to add in the area of the square. All right, so let's take a look. Nice square area right there. This is 16 since it's a square. All right, 16 times 16. And you will then be able to add the two together. All right, so we have 544 plus 256. And how about that? And even 800 square inches. All right, so that's how you find surface area again. You find the area of all of the faces, and then you add them together. All right, how about this one? Let's use a net to find the surface area of the pyramid. All right, so this one doesn't provide you the net, but we're going to think about what we just talked about, right? So we have 4 triangles. All right, so I'm going to use my triangle formula now, 1/2 base times height. All right, so what do I have? My base is 16. My height is 20. And 1/2 of that. All right, so again, I want to use friendly numbers. I could go from left to right, and I might as well. I guess I was going to take 1/2 of 20, and that's 10. to do that one in my head, but I can do the other way as well, right? So 1/2 of 16 again is 8. 8 times 20 is 160. All right, so we have 4 of those now. And now let's take a look at our bottom. All right, so our bottom again is 16 times 16, which is my square. And again, we did that on the other page, but I'll do it again right here just to show my work. So we have 256. All right, so now I do my 160, my triangles times 4. So that's 640. I'm going to add that to 256. And I have 896 square inches. All right, so same idea. I found the area of my square, my base, and then I added it to my 4 triangles that go around and they fold in to make that point. All right, let's look at this one now. This is going to be surface area of a prism. A prism is a 3-dimensional figure whose 2 identical and parallel bases that are polygons. All right, the other faces are rectangles. All right, so it's going to depend on what the shape of the base is. So a prism is always defined and identified by the shape of its base. So let's look at our word problem. A sculpture sits on a pedestal in the shape of a square prism. The side lengths of a base of the prism are 3 feet. The length of the prism is 4. The height of the prism is 4 feet. The museum director wants to cover all but the underside of the pedestal with foil that costs 22 cents per square foot. How much will the foil cost? All right, so we were doing those multi-step word problems before with the paint. So you kind of have the same thing here. You got to find, first of all, the area. So we're going to look at our breakdown here. All right, so you see our net. We have the square base right there, which makes that prism what it is. And then we're going to have our rectangular sides. All right, so the whole idea is you got to find the area of the base. We have a square, 3 times 3, which is 9, and then all of our rectangles now are 4 times 3, base times height, right? So we have 12, 12, 12, and 12. All right, so we have 4 times 12, which is 48, and we add that to our square base, which is 9. All right, and we don't have the bottom to cover with foil as well. All right, so what we're going to do then is we're not going to add that 6th side. So it's very, very important to remember. Oops, sorry about that, 57. All right, so we have 57 square feet to be covered. And then what you do is it was 22 cents per square foot. So you're going to multiply now 0.22 times 57. And then when you do that, probably already see the answer there. That is what you get, $12.54. All right, so always pay attention to that word problem. I'm just going to go back to for a second. All right, so you'll see the museum director wants to cover all but the underside of the pedestal. All right, so all but the underside. All right, so that is meaning that one of those squares is not going to be covered. So if it was technically completely covered, you would add another 9 to it. All right, and you would get 66 square feet. All right, so you got to be just careful what they're asking for. All right, so those are good thinking problems. All right, so here's another one. The figure shown is a triangular prism. How much would it cost to cover the bases and the other 3 faces with foil that cost 22 cents per square foot? All right, so are we covering the whole thing here? It says the bases and then the other 3. All right, so that is going to be a yes. And you can just count again. My faces are here, 1 on the top, 1 on the bottom, and then my 3 rectangles going around. All right, so however you want to do it, I'm going to start with the triangle first, so 1/2 base times height. All right, so again, just to draw out my shape, I'm going to have triangle, and then I'm going to have my 3 rectangles going across, and then I'm going to have my other rectangle on the bottom. So I have 5 faces right there. So I'm going to break it down. All right, so what's my 1/2 base times height? There's my triangle right there. It has a right angle, so I'm just going to rewrite it right there so it's a little bit easier to see. All right, so my base would be 3. My height would be 4, depending on how you're looking at it, okay? So there we go, 1/2 base times height, that's 12.6, all right? So 6 square feet, so that would go there. So I'm gonna multiply that times 2, right, to get my total triangles. All right, so that's 12. And now I'm going to do my square, all right? So, or my rectangle, rather. All right, so my 3 rectangles, All right, so you see here now, this is where you got to be really, really careful not to get confused, because if we're using wrong numbers here, then it's going to throw us off. All right, so we have to. I have different dimensions there, right? So I'm going to have to draw it out now, so I'm not confused. All right. So here we go. Let's start with the first rectangle, and you'll see how that's right there. I have my 5 times my 2, right? So that's 5 times 2. That's 10. All right, so here's my next rectangle. I'm going to change it to yellow. So now I have the edge with the 4, right? And so that's going to be 4 times my height, which is also 2. All right, so that's 4 times 2. So that's 8. And then lastly, my last rectangle is right here. I'm going to change it to, let's change it to blue. All right, so we have my base is 3, and then my height is 2. All right, so 3 times 2. All right, so there we go. There's my 5 faces. If it was the same rectangle for each, I could have multiplied it by 3, but I can't, so correction there. All right, so I noticed that when I was looking at the different dimensions, right? So I have my 3 different rectangles. 10 plus 8 is 18 plus 6. 18 plus 6 is 24. I add that to my 2 triangles that I had from before. So 36 square feet. Still not done. So you can see these multi-step problems. This would have been a good state test problem. So it's 36 square feet times 22 cents. All right. So now I need to do my math. Do it a different color so you guys can see it here. 72. So 297. So $7.92 would be the cost to cover that with foil. All right, so again, this is how you're going to do it. You're going to see an example like this just in a minute. So here's your square pyramid again. You have your base, you have your square. Again, when you're showing your work, just put the number on the inside. So we have our square, 6 times 6, 36. And now we're going to have our triangles going around here, 4 times. So take a look at my triangle. The base of my triangle is going across. That would be 6. My height is 4. 1/2 base times height is 6 times 4, 24. 1/2 of that is 12, or 1/2 6, which is 3, times 4, which is 12. All right, so I have 12 of those, or I have 12 square inches times 1, 2, 3, 4. All right, so that's 48 for my triangles, and I'm going to add my square, and I finish off 84 square inches. All right, and then last one here. All right, what is the surface area here? Take a look at my base. My base is going to be the rectangle 10 times 6. All right, so that equals 60. And I'm going to have that on the top and bottom. All right, so I'm going to times that by 2, so I'm just going to do that again. All right, so those are my 2 faces. Now I need to have my rectangles going around. All right, so here we go. I have 10 times 6 right here, so that's going to be 10 times 4 going up, 10 times 4. So 40 is this face right there. All right, and then there's one on the opposite side, right? So that's 40. And then I have this shape right here. I have 6 times my height. Let me erase that so you can see it. So 6 times 4. I'm going to change my color to red. So that's going to be this rectangle now. 6 times 4. That's 24. And I'm going to do that 2 times. All right. So you can see there's my 6 faces. 1, 2, 3, 4, 5, 6. All right, I'm just going to put the 2 together. Just make it a little bit easier to add. So that's 120. Put those 2 together. That's 80. See how nice this sets up? Those 2 are going to go together to make 200. Then lastly, I have my 224s to get to 48. So 248. Take a look at this now. So now I have more steps to the problems. All right, so find this total surface area of 100 boxes. So times 100, what am I going to do? I'm going to add 2 zeros to it. All right, so I have 24,800. 1 can of paint will cover 14,000 square inches. How many cans of paint will Yolanda need to buy? And you guys are getting better at that, right? You guys could divide, but some of you guys are seeing it right away that 14,000 is 1 can. 2 cans is going to get me another, and that's going to get to 28,000. All right, so technically I'm going to have leftover if I have my second can, but I can't buy a decimal of a can. All right, so that would be 2 cans of paint. All right, so here we go. There's our lesson for today. So you guys are going to be breaking this down. So take a look at the top. You have the net, and again, you have your different uh, triangles and squares there. This one you're going to break down. So I need to see that triangle there. So 1/2 base times height, right? You see there's your base and your height right there. Then you're going to have 1, 2 of those. All right, and then you're going to have your different rectangles right here. So take a look. There's your height of your rectangle, and then you're going to have 2 going this way. Uh, and then, oh, I covered it so I can't even see. All right, so you got to be careful now with your different rectangle because you have the 3 different dimensions, right? So you're going to have to use each of those with the height. All right, so again, I would draw that one out. You're going to have your 2 triangles times 2, and then you're going to have 3 different rectangles, all right, just like that one that we had seen on the problem. All right, so find that separately and then add those 5 sides together. And then this one is just like the last example. All right, then you have 5 boxes, and then you're trying to figure out how much the fabric is going to cost. All right, so these are the ideas here. All right, so it's important to understand where surface area comes from. It comes from each of the areas of the different faces on your shape, and then you add them all together. All right, any questions? I'll be available to help you guys in the afternoon, so let me know. And I'm going to do this again. I'm going to put this on both the worksheet and Jamboard if you want to use that. Those of you that need some help, it's always easier for me to have you log in onto your Jamboard so I can see what you're writing, and then that way I can help you with your work and what you're doing with each dimension as well. All right, have a good one, and let me know if you need help.